Hello, my name is Kaylee McPhail, and this is my presentation of my research, Do the Short Die Young, a comparative study of the growth patterns of children in post-medieval and medieval Europe. So the main purposes of the research are to discover if childhood mortality has a determining impact on the population structure of communities, whether or not infants and juveniles are truly representative of their overall population, the selective mortality, and whether or not height impacted survival during this time period, and what health issues were faced by pre-industrial children based on class, location, status, etc. And so for this presentation, I'm going to be focusing on one cemetery in particular, Villa Magna. Villa Magna consists of the villa and surrounding cemeteries in Villa Magna, Italy. And these cemeteries were in operation from the 5th century until the late 15th century. However, the data is mostly from between the 11th and 13th centuries. The data was received from the Villa Magna project, which is still in operation, and the sample used consisted of 125 adults and 44 children, which are also called subadults. So if I switch between the two terms, they mean the same thing. And so our project uses existing data from known sources to plot the growth curve of children, modeling the curve using adults of the same populations and then comparing it to World Health Organization data of modern populations. For this project, I'm using what is called the Usher model after Dr. Usher, in which the statures of the immature and mature samples are plotted on a scatter plot with data from WHO on the average height of modern populations and the normalized statures of the sample population. The mean of the skeletal data for the mature sample is divided by the WHO mean population data in order to determine the normalization factor for adult males, females, and unsexed. This is then multiplied by the respective WHO mean statures to determine the normalized statures for the sample population. The comparison between the normalized statures and the original skeletal statures, which were calculated using Ruff's formula and Trotter and Gleason's formula, depending on age, can be used to determine whether the immature individuals in the sample population are taller or shorter than their contemporaries in their population, and whether there's any trend in the data regarding their stature. And so this is what the curve looks like. The statures of the immature mature samples are plotted on this scatter plot with WHO average height between the tallest males and the shortest females in order to get that kind of shaded area. And that would be then plotted with the normalized statures, which would be the expected height of the sample population for all ages. This allows us to determine whether or not the children in the population are taller or shorter than their contemporaries. It also helps us determine if there's any trend in the data regarding the population stature, specifically the children's stature. And this draw conclusions on whether they died as a result of their shorter stature. For Villa Magna, it's a little different. They are all much taller than they were expected to be, as you can see by the growth curve at the bottom of the shade area and the red dots representing the subadults of the data. They are significantly taller than they were supposed to be. We then calculate the residual, which is the difference between the found value and the expected value. They will be calculated by subtracting the normalized stature from the calculated stature for each individual, and it was calculated for everyone in the data set using unsexed normalized stature. It was then calculated for each adult using a female or male normalized stature in order to determine the sexed residuals to make the data a bit more accurate. This allowed us to determine how far the heights are from where they should be. The zero line, that black line right across about the middle, is where there would be no difference between the found and expected values. For Villa Magna, they're absolutely everywhere. Now, the residual allows us to find how much shorter or taller on average the subadults are than the overall sample population. For Villa Magna data, the residuals begin to become closer to zero as they become older, showing that the gap between the stature of the individuals in the sample and their contemporaries who survived to adulthood, represented by the normalized stature, is becoming smaller as they get older. But during their younger ages, most especially between 2 and 12, they're everywhere. They're either much taller or a bit shorter than they should have been. So the results for the sample is that the subadults were consistently on par or even slightly taller when compared to the actual statures of adults in their population and the calculated normalized stature. This cemetery complicates our original hypothesis, which was that the shorter individuals would be the ones dying younger, and the ones who lived and survived until adulthood would be the ones nearer the expected height. The residuals are also extremely varied in this population, meaning that height didn't play as large a role in the mortality of the children in the cemetery, as was the case in the other cemeteries in the project. Now, between the 11th and 13th century, this region experienced a period of abundance. Agriculture increased, everyone experienced improved conditions, regardless of their status, class, location, etc. And these improved conditions may explain the disproportionate representation of taller kids, because better conditions could have led to an increased stature. But why did they all die young? The hypothesis right now is that the conditions went from amazingly good to catastrophically bad during this period because disease actually ravaged the region. So, multiple diseases devastated the population during the years with the greatest number of subadults buried in the cemetery, most notably being the bubonic plague. Acute diseases like these are more likely to affect the entire population, regardless of their status, class, height, and especially novel diseases that have never been seen before. Long-term stressors are more likely to disproportionately target shorter individuals. So the presence of acute disease could explain the presence of taller individuals in the cemetery. Now, for future research, we're in the process of finalizing the style guide for and layout of the paper, and we're in the process of writing and publishing the paper on our findings using multiple cemetery populations from around the globe. And if you have any questions, please feel free to contact me. Thank you so much for watching.